So we now move to the open part of the meeting for questions.
Hi, I'm Tom Franklin. Thanks, that was a very interesting talk. The thing that kept going through my mind, perhaps because I was doing something about it many, many years ago, is that you seem to have a very monotonic world. Just to give a very simple example, you've got Peter as a professor and Professor as an employee. But if I then tell you that actually Peter is a Professor Emeritus, he's no longer an employee, and the whole world is like that, it's terribly messy. And doesn't that completely mess up your ontologies, because everything has infinite number of possibilities and you basically have to work with the uncertainty? How do you handle that?
Well, part of the work, for example, in this integration between ontologies and rules was exactly about these kinds of things. So the idea is also that you can actually represent exceptions. So the idea was to also integrate certain aspects of non-monotonic reasoning into ontologies. So, I mean, in the end, you know, you've got a logical theory which is either monotonic or non-monotonic. What I try to do as a researcher is to try to provide you with options, and then you have to choose which one fits your particular use case best. But, I mean, I'm fully aware, so fully monotonic systems in map, I mean, I agree they won't be able to necessarily handle all use cases, and quite a bit of research was done in exactly addressing that issue.
Hi, Chris Andrews, IBM and BCS trustee. I think, having worked in the industry for a long time, I think most information architects already are quite a good combination of scruffy and neat, practicing ones. Following on from the point over there, the thing that I feel is missing, and I don't know if you've considered it, is how do you deal with emotion and intonation, particularly with things like sentiment analysis and Twitter feeds, where the word wow and how it's emotively said changes its entire meaning and how you would analyze the semantic structure.
To be perfectly honest, I mean, this type of stuff we haven't done using logic. I mean, there was a lot of research in modal logics, for example, where the idea was to express some kind of attitude. But I mean, this towards the subject, but this is not reflected in these standards that I mentioned here. These standards are more used for really structuring your data, which is somehow objective. So I have to just basically say, I mean, I haven't done it.
Yeah, I think what you've done works very well in a factual industry, but I think in the retail and telecommunications and when you're dealing with customers and human beings in the main, they tend to imply emotion in it, and you can often use words in the opposite context to mean the opposite thing just by changing the intonation. And I think that's one of the challenges we have, you know, we face in getting this to work. And I think it's a very good structure for a class of problems, and it moves things forwards. But I think, you know, for a large portion of what we deal with, you know, sentiment is a huge issue, and it changes how we have to react.
Sure, I completely agree. I mean,
yeah.
And I know that, I mean, in our department there is even a spin-out actually related to sentiment analysis, but I think at the moment they actually are using different kinds of techniques, more inspired by machine learning, I think. So, I mean, sure, it's an interesting research problem to try and bring these two together, but I haven't done anything on that, I'm sorry.
But I want to say thank you for trying to bring theory and practice together. I think that is really important. It's great, thank you.
I was really interested by the lecture and where you started from with the failing Google search. And then you described the veneer of putting the ontology over a massive data. And then you talked about setting up these complex problems, but obviously using the logic that requires a computer scientist to understand. What really interests me is taking that a step further and getting the logic to speak to the user interface so that you could, for example, enrich the data so that we know that a hotel is a form of accommodation, make the question domain specific, add to the syntax in the user interface so that you can create domain-specific queries on that massive data. So that, for example, you can say that a stop is part of the Alsatian's face in this domain. It's not what the word stop means in any other domain. Or, for example, if you were querying hotels close by the Colosseum, the query could return to you and say, are you sure you're only interested in hotels? Could you be interested in bed and breakfast? This sort of thing. Is there anything being done to improve the user experience using these techniques?
I personally haven't done that myself, but yes, a lot is being done in various different fields. So, for example, the actual company Experience On, they did exactly something like you just suggested. They used their ontology to actually suggest possible other kinds of queries. Now, I think they're actually quite a good combination. I mean, I was really impressed with the people there. They were maybe to a certain extent scruffy neats, or maybe neat scruffies. And they actually came up with some really good ideas on how to solve that problem, even in an industrial setting. But then a lot has been done in research also to address this kind of issues, like informal concept analysis. In the group where I did my PhD, some people tried to explore this formal concept analysis to somehow suggest, possible query refinements. Then a lot of people who do linguistics, computational linguistics, they try to bridge this gap between natural language and formal language. So there was a lot of work in trying to understand, for example, English and translate it into these queries. Again, these people in Experience On had a really interesting solution where they tried to use the ontology to generate lots and lots of queries and then index them using Lucene. And I was really impressed, and it seems to be working really well. So yes, a lot of people are doing that, but my personal research wasn't really on these kinds of topics. So it was more really on the, shall we say, the back-end side. So once you've got your ontology, then you have to process it in a particular way, and that's basically what I've been doing.
Thank you.
Brunella Lungo, thank you for your talk. I was wondering, compared to clustering, that solved the Google problem or tried to address the user expectation in respect of the problem you mentioned at the starting of your talk. How ontologies apply or provide, comparative solutions?
It's a good question. I mean, so at the moment, I have to admit that there hasn't been a lot of integration between more machine learning style approaches and more formal approaches. And this is clearly something very interesting that is awaiting someone to really try and address it. And I mean, at the moment, you're basically doing one or the other. And the difference is that in machine learning, the intelligence is somehow emergent. You have your training data and you train your SVMs or whatever type of algorithm you use, and somehow there are these weights in your neural network and they somehow encode the knowledge. Whereas here, the different approach is that you as the user have to invest many years sometimes to actually come up with a logical theory which explains what it's all about. Clearly, I mean, there was a lot of work, maybe I'm actually exaggerating when I'm saying that this wasn't actually considered. So there was a lot of work on trying to learn ontologies from, let's say, text, with, I would say, some success. I mean, it's a very difficult problem, but there the idea wasn't really, the idea was to use machine learning more for just creating the ontology, and then you throw your machine learning away and you basically just use the ontology. Yes, I mean, I agree that, apart from that, it would be interesting to somehow try to use both synergistically, but it's somehow difficult, because they start from completely different ends, and, maybe, the next Roger Needham, maybe next year, some person is going to tell you exactly how this works. So let's hope that this is the case.
I'm Christina Luca from Anglia Ruskin University. I was wondering, what do you use to query the ontologies? Because we have Sparkle, this is a standard, but it has its own limitations. And then what I found is, even if we work on the ontologies, we can get wrong results just because a query language is not strong or good enough.
What do you mean? I mean, the query language has a particular semantics. And
yes.
I mean, if you implement that query language, then it's about formulating the right query. At least this is what I would initially tell you. So just ask the query that you want to ask. What do you mean wrong results? Wrong in what sense?
Perhaps not what... Right, perhaps wrong is a wrong word.
Counterintuitive, maybe.
Yes, yes.
Okay.
So given that Sparkle is not and was probably not strong enough, and it has some limitation. If we use it, does it have an impact on?
So what I would tell you that in that particular situation is come and speak to me. I would be really interested to see your use case and why this particular query goes pear-shaped. So we can either fix the query or extend Sparkle. And this was a running theme through my research anyway. So yes, by all means, please speak to me after the talk, and we can have a look at that.
All right, thank you.
Sean Barker, BAE Systems. Following on from that, how well is Sparkle matched to OWL? Are there questions you can ask in Sparkle that you can't ask in OWL or in certain categories of OWL? And equally, are there some things that you could say in OWL that you can't ask in Sparkle?
I wouldn't see it as like that. I mean, Sparkle somehow complements OWL. That's how I view it, basically. I mean, OWL by itself is just an ontology language, and then you can use maybe certain elements of OWL and turn them into a query language, but it's not a fully fledged query like a retrieval language, whereas Sparkle is. And I mean, there was quite a lot of work in the 1.1 version of Sparkle to try and make it work even better with OWL. And I think the current solution, I mean, sure, it maybe has like a few glitches here and there, but I think on the whole it works reasonably well. So, I mean, the expressivity is different because these two things address different problems, but I think they do work reasonably well, although the interface may be a bit more complicated. So what we could do is we could maybe explain this in a slightly better way to users.
Tony Law, I used to work for BP, so your Statoil example resonated with me quite a lot. I'm not sure I can express this very well, but this goes back to some of the work I was doing then, and this is 30 years ago, with text databases using thesaurus structures, which of course had broader and narrower terms, which are similar in a way to your hierarchical ontologies. But experience was that sometimes you wanted to climb the hierarchy in one direction, and sometimes you wanted to do it in the other. And perhaps the closest example is to pick your educational institution example and say, if you're trying to look at what's going on in educational institutions in the UK, you want to look at universities and you want to look at Oxford and Cambridge and Manchester and Kent and all the rest of them, and you want to look perhaps at what's going on in schools and technical institutes and so on. But if you're in, say, Oxford University and you're trying to find out what legislation and regulation applies to you, you'll want to look at, I mean, there might be things that are specific to yourself, there might be things that are set at university level, there might be things that are set at educational institutions as a whole. So you need to climb the hierarchy in the opposite direction. How do you actually handle that in your framework?
Well, in an ontology, you just have a hierarchy, and then it's about asking the appropriate question. I mean, you can ask a question upwards, or you can ask a question downwards. I mean, it's basically application specific. I mean, an ontology represents the hierarchy as it is, and you can draw conclusions from the ontology and the hierarchy as they are, and that's basically it. I mean, it's up to the application to then interpret this hierarchy in one way or the other.
Okay, so welcome everybody. First of all, I would like to thank the BCS Academy and Roger Marshall, its awards committee, and the CPHC for their sterling work in advancing computer science as a discipline, part of which is recognizing and awarding excellence, and thus giving us all the great opportunity to be here tonight and celebrate outstanding contributions. Next, I would like to congratulate Adam Pocock, Joanna Oljewska, and Boris Motik for their achievements, which we are celebrating tonight. And I wish them all the best for their future. I would like to say thank you very much for Boris for his inspiring lecture that he gave here, and where he gave a great view of the impressive, broad, and trailblazing work that he has done in the last decade, plus minus some years. Most research working in these areas won't invent any new reasoning paradigm in their whole lifetime. Some researchers invent or reinvent one. Boris, I thought had invented 2, but I think he has now invented 3. So this is most impressive. And not only did he invent those reasoning paradigms, but he also proved them to be correct. He established computational complexity results, etc. And he engineered those into highly performant reasoners based on those paradigms. Those reasoners challenged our preconception as to what is and isn't computationally feasible and how high performance can be achieved in this area. In a nutshell, his body of work is a great example of my favorite kind of work in computer science. It has solid theoretical backing, it involves some very clever engineering, and it is evaluated in thorough fieldwork on existing challenging problems. So thanks, Boris, again for your work. Next, I also want to mention Ian Horrocks, Boris' friend and mentor. He also won the Roger Needham Award in 2005 and was recently made a Fellow of the Royal Society, and we are guests of the Society tonight, and so this gives us the great opportunity to be in this very awe-inspiring location. So thanks to the Royal Society for hosting us. And I mean, Ian, given Boris's talent and ambition, we may doubt whether he needed a mentor to be where he was today, but I'm sure that it's partly thanks to you and your guidance that he is here today as a Roger Needham Award winner and a UK academic. Finally, I would like to say thanks to the audience for coming here tonight and for joining us all in celebrating excellent research in computer science.
Thank you again, Boris. So that's the end of our formal proceedings tonight. Those of you who are staying behind, we've got refreshments out in the ante-room there. So just to echo what Uli said about thanking you for coming tonight, hope you've enjoyed it, and see you again next year. Thank you.